Hello everyone and welcome to IP Solutions and this little tech talk, or maybe I should call it a tech seminar. This is a short little seminar about SIP with the subtitle, Is it really that complicated? The reason we created this seminar is that we quite often have students attending our SIP courses and they always want to get into the really complicated and advanced and cool stuff straight away without knowing the fundamentals first. And of course, if you learn SIP or just hear about it or Google about it and so on, it sounds really simple. I mean, if you've worked with SIP, you know it's an invite request, it's a few 180, 200 and then an ACK request, and then the call is established. And often you compare SIP to email or HTTP and the web and email. How complicated can it be? So I created this seminar to give people an idea of what is really complicated. What is there to learn in detail that actually does or causes us to recommend that you really should attend first a basic course, then our advanced course, before you try and learn the advanced stuff. There are several times after a 5-day course in both SIP Advanced and SIP Troubleshooting where I've gotten students telling me after the course that I thought I knew SIP before I came to the course. I even thought that myself once. 10 years ago when I had been teaching SIP for a few years already, and then I became a SIP developer. So I had to write a SIP stack from scratch. And I thought I was really good at SIP already then, but I wasn't actually quite right about that. There was a lot more to learn. So the idea here that I will simply point out a lot of issues in SIP and a lot of functions in SIP that actually requires quite a lot of knowledge to be able to understand how it works, why it works, and why it may not work. So let's get going. Now, SIP, my way of simply explaining it, and I said a little bit already, that I mean SIP is based on email, or you could say that SIP is based on HTTP, which is even more accurate, but HTTP in turn is in a way based on email, so it's true both of them. And that makes it easy to think that it's very simple. When you send an email, you create a text format message, you send it to your mail server, the mail server will use DNS to find the destination mail server, so it goes down to that mail server, and then the destination is sitting there and polling the mail server getting their email. It doesn't sound that complicated. And SIP is quite similar. Instead of sending it to a mail server, we're sending it to a local proxy. That proxy will use DNS to find the destination proxy, which will eventually figure out that the user with the SIP phone is registered somewhere and send it out to that phone. So a little bit of real-time or interactiveness compared to email where you had to poll or check the mail server. In SIP, you know that we register to the registrar instead, where we record our current IP address. And that makes it more sort of interactive or real-time. And you should also already know, of course, that these SIP messages, the SIP requests that we send, they also contain the session description protocol for negotiating the media channels that we use for the voice or the video or whatever we use it for. So far, it doesn't sound that complicated. It was based on HTTP, which in HTTP we send a GET request to download a web file or a web page of some sort. In SIP, we've got a lot of other commands like invite, ACK, cancel by, options, register. Do you know what all those are for? Well, invite is of course the one we use for making calls, but what about cancel? Well, we terminate calls that haven't been started yet. By is fairly obvious, terminating calls that have been started. But what about options? What do we need that one for? Register is hopefully also obvious. We need to register our current IP address. How long are we registered? When do we need to re-register, of course, an issue? The really actually quite tricky one is usually when you start talking about ACK. Why have we got ACK? And even more importantly, if you look at the call setup of a session, okay, so you use invite to set up the call. It contains an attachment with SDP, and then there are various kinds of responses to indicate progress, and 200 indicates that the call has been fully established on the B side. But then we've got an ACK. Why are we sending that one? It might feel obvious that it's for reliability, but then why aren't we sending it down here? When you send by to terminate the call, the other side responds with 200 and no ACK. Why do we have that difference? If we look at the different responses that a device can send, well, we can choose from 1, 2, 3, 4, 5, 6 If you compare it to HTTP, it only had 1, 2, 3, 4, 5, and I don't think 1 was very common. So why have we got 6 in SIP? Is it so bad that we need an additional error response code or error response class? Well, it turns out we can do something in SIP that we couldn't do in HTTP. What's that? So quite a lot of differences here. We can even go into the differences between 200 and all these other underlined so-called final responses. Can you send more of them from a client? No. Can you send more provisional ones? Well, yeah, we can send 100 trying, we can send 180, and we can send multiple 180s. But rules like that, you need to know those if you're troubleshooting and trying to figure out are the clients behaving correctly. And this 200, when it's received by this proxy, as the image is trying to illustrate, it goes straight through. But if that same proxy received a 3xx or a 4xx, say for instance 486 busy, would the proxy just let that through? Probably not. It would actually send ACK. Why? If we're troubleshooting this, we need to know how the devices should behave so that we can identify when they fail. The message syntax, it's text, and that sort of automatically makes us think it's easy. Okay, so we've got from and to, max forwards, what's that for? Call ID, what's that for? CSEC is even more complicated. Why do we need that one? Well, it has to do with simple retransmission identification and so on. What's the via for? Why do we need that one? If you compare it to HTTP, we didn't have a via header, and from and to, of course, we didn't have those either. So just understanding what they're for, and the fact that in every SIP request, you must have certain headers. They're mandatory headers. When a client sends a SIP request towards a destination, and that destination starts generating the response, how should the headers look in the response compared to the request? There are a bunch of rules inside the SIP Bible, the 3261 standard. It describes exactly how you generate a response based on the incoming request. And the rules, of course, up here define exactly which of these headers that you must have in every single request. What are these tags for out here? When do we need those? If you look in an initial invite, there is a tag on the from header, but there's no tag on the to header. Why not? So all those rules are quite important to be able to identify how these systems should behave. And then, of course, the proxy or the proxies in between these clients. When they see these messages, what are they allowed to do with them? Is the proxy allowed to modify these headers if he wants to? If the proxy decides to send the call to 3 different destinations, one after the other, could he possibly change the to header to guide it to different destinations? Proxy has very strict rules on what it's allowed to do. But what if we need to? What if we build an application that wants to change? Then what do we do? Well, that's where the back-to-back user agents come in. Then we have to understand what they do. UAC and UAS is something you hear a lot when you start digging into the detailed rules of SIP. And that's because our standard document down here, the RFC, will describe the rules in terms of what the original creator of the request must do, what the sender, the original creator of the response, must do, and then also separately what a proxy must and must not do. So that's why we have those phrases, to be able to clearly give the rules of the protocols. Then, of course, one simple thing that's easy to forget is the syntax we're seeing up here. It says from : and then we've got the SIP address afterwards here. But what about the colon and the SIP address? Can we put a space in between there? Can we put a space in front of the colon after the M? Can we put a tab? I mean, it's white space, so maybe it's not a big deal. We have to have that standardized so that you can buy one product, one phone from one manufacturer, a proxy from a second manufacturer, and a client from a third manufacturer, and they should still accept the same messages, even if they personally use their own syntax rules. We have to follow some kind of standardized syntax rules. And the word for that is this strange word, augmented BNF, augmented Bacchus-Naur form. Of course, it's part of the RFC. It's the same format, or an augmented format compared to what you use in email. But to be able to fully validate a SIP message, we have to understand this kind of syntax. This is an example of ABNF, which describes how a from header, what parts it consists of. For instance, you can see it says F or from here, which means that you can actually receive a from message where it only says F colon up here. The to can probably, if I remember correctly, be abbreviated to just a T. The contact header, I think, can be abbreviated to M colon. So there's an old heritage here from other protocols like email and HTTP that causes this syntax rule to be quite complicated, but we have to support it and we have to understand it if we're really going to troubleshoot SIP. So here we've got an example. Looks like a fairly simple call. It's Alice calling Bob. Alice in lab 1, Bob in lab 2. We can see how we're starting. Alice is starting requesting a session with audio and video towards Bob. And what we're looking at are the messages as they go out of each device. So Alice sends this message and then we can see directly coming out of Bob's phone when he answers this. We can indicate on the via headers that tells us which path the message went. But if you're not really used to SIP, why the heck does it say from Alice when this is sent by Bob? It's supposed to say that, but still, why? If we start looking at the SDP, is that a valid SDP? Are you allowed to answer this SDP with the SDP in the right side? Well, then you have to, okay, so Alice wants an audio session. She gives a suggestion of codecs here. But if we look on the other side, 96 and 122 are on the list, but we don't even have them on this side. So are you really allowed to do that? There's even a worse thing here. Turns out that is actually legal, the way that is done. However, if you look at the M video line here, that's gone from the B side. There's actually quite a few systems that do this. If they find a video line or a media line they don't want, they strip it off, which is completely illegal according to the SIP rules. So there's quite a few things to learn here. How do you do call hold? If you have a call going and then you want to just pause the other side, how do you do that? How do you modify the session if you want to temporarily add video for a second and then remove it after a while? How do you modify these messages? There's a few bytes or numbers here that need to be modified every time you change something. A call could even be established this way, where you send an invite where the initial invite doesn't even contain SDP. Why on earth would you want that? No normal phone should normally use it, but there are some use cases that need to use that kind of session setup, which means that every receiver has to support receiving an invite without SDP, and then we'd send it in 200 and ACK instead. So there's quite a few rules on how to set up your session. And all the rules that we could have gone through in the previous slide on how to modify the SDP, all of those have been put into a separate standard. Now our Bible, 3261, it says that we should follow 3264 and that the messages, according to that rule, are only allowed to be in certain messages. And as you see, the rule may start off easy, saying invite and ACK, because we have ACK here as an example and invite is the normal one. But then it starts getting a little bit more fuzzy, saying first reliable non-failure response. And it turns out there is an even other annoying extra rule about putting SDP in provisional responses. And if you've ever had problems with almost all my students when I talk about it, they sort of, they nod knowingly. If you've ever had problems with ringtone generation or one-way media, then understanding these rules, my belief is that because of the misunderstanding of how these rules work, has caused a lot of issues with ringtone generation when you're interworking between classic telecom networks and SIP. Another big thing that we spend a little bit of time on is transport selection. When a device sends a SIP message, should he use UDP or TCP? It's not just an easy, some people say that, oh, well, SIP uses UDP as default. Well, it depends really what you mean by default. SIP can use all the different protocols, but each hop can decide on its own. It's nothing that the first hop decides what protocol to use. And we need to have rules for this. Turns out the request size is involved in this, DNS is involved in this, the URI can indicate what transport protocol to use. And this could mean that my scenario here, where one hop is using UDP, one is using TLS, and the last is using TCP again, is completely possible. And that could cause that even though your initial invite goes over UDP, When you then send the ACK for final confirmation, that goes over TCP. What about responses then? Well, it turns out they use the same transport protocol as the request. But this is definitely important to understand when you start troubleshooting. And if you start configuring DNS for your servers and so on, then you really need to learn that DNS is used in a lot more advanced way than the way we've been using it for web servers and so on. Because as you can see here, there's a lot of records involved in using SIP and DNS. Now, we could say a little bit more about the via header. I'm not going to say that much, but if you look at a via header, this is one example. It has DNS in here. That looks a bit weird. You probably already know that the via header is what gets the responses back to us. It's not just automatically sent back to where it came from. But if we're going to send it back to where it came from, okay, so we've got an address in here, but adding DNS, that could be slow if you have to do DNS lookups when a response comes back. So how is the value really used? Are there any other parameters? And what about TCP? If you establish a TCP channel here, will the response use the same channel? What if you tear it down? There's quite a few rules here. Registration. Doesn't sound that complicated either. You send in a register message and you tell the server, here I am right now, by adding this contact header. That indicates your current registration. But in NAT scenarios, what if I use my mobile here and turn on my SIP client? And then on my 4G connection, I get a private IP address, 10.1 something. And then I start my laptop on our local Wi-Fi here at the office, and I get the same 10.1 something. Those SIP registrations, when they enter the registrar, would look like they're coming from the same device maybe, because they're using the same contact field. Now that's part of a NAT issue, of course, network address translation, but there's a few other interesting issues that you need to be aware of when it comes to registration. How do we prioritize different clients if you register multiple of them? Deregistration can be done in different ways. Can you send a register without contact? And why would you want to? Turns out you can, and there's actually a slight use for it. When you get a response, of course, okay, do you need to check anything in here? Or is it just send your message and then hope for the best, and when you get a 200 everything is fine? Turns out there's one thing you need to check in here for safety's sake. One new feature that has popped up in SIP, it's quite old, but it hasn't been been used that much until lately now with Volta networks and so on. And that is two things called caller preferences or callee capabilities. When you make a call to someone, can you make sure it ends up on a terminal that supports video? Not without these extensions. If you do, then you're just lucky. We need to update registration mechanisms so that the phones can register what they're capable of. But it doesn't help if our invite can't actually tell the network we want to end up on certain capabilities. So that's quite an important feature that was added quite a long time in an RFC called 38, 40 and 41, but it hasn't actually been used that much until quite lately. A heavily or super important issue in SIP is the SIP dialog. So what is the SIP dialog? Well, it's what we create when we start invite, when we create a session. So we send invite to someone, it starts ringing, eventually they answer, we might have some packet loss, and then when they answer we send a confirmation and that starts the call, but it turns out it also starts the dialog. And why that is so important? Well, it turns out then that when we start sending messages after the call is established, messages associated with the dialog, even the ACK is a message associated with the dialog. But we might send bye to terminate the call, or you're talking to someone and you want to send them an instant message to the phone that you're talking with them on, then all those messages have to follow a certain path. They're known as in-dialog requests. And there's a big bunch of rules on how you create and where you send those messages, because they have to follow a certain path. And that rules is the thing we talk a lot about in the courses is what's known as Dialog State. That on each side, when you have a phone call between two terminals, there's a lot of parameters that each side has to remember and use for as long as this call is running. So every request that is sent, you have to, if you're troubleshooting a call that has problems, then you have to validate that the terminals and any back-to-back user agent is really using these parameters correctly. Classic routing. I come from an IP background, so working with routers and switches and so on is sort of second nature to me, which means one of the things I sort of think about a lot with SIP is just routing. How do the messages find their way to the destination? First off, what do we route on? If you send a request into a proxy, what is it looks at in the message to send to the next destination? When I ask that of students on a SIP troubleshooting course, I quite often still get people answering the to header. But that's not true. We have a request URI at the top of the message, and that is what's routing the message. That is the destination address, the current final destination. And that value may change or will change as the message moves through the network. So that's a really important thing. What if this proxy here wants to force the traffic a certain path? It doesn't just want to send it to the destination, it wants to force it to servers. Well, then there's policy rules, and once you start inserting weird route headers. Those route headers will contain the weird keyword LR, standing for loose record or loose route, and later on we're going to start seeing messages that contain these record route headers. What are they for? Well, they're also part of this dialog stuff that we talked about a few seconds ago, and they are super important to be able to validate and check your calls and just basically understand how SIP messages are forwarded. They're the ones who guide that our in dialog messages are sent the right path. And that LR thing stood for loose route. What if we remove it? Turns out it doesn't actually have to be there. Very old SIP systems won't even add it. We want it there so we know it's a new client, but there are backwards compatibility mechanisms we should support as well. So you could accidentally run into places where that isn't in there, that LR. One of the big things with SIP that it sort of brags about is its flexibility, extensibility, and the fact that we can easily add new mechanisms, new services to it. So how do we do that? What should a proxy do if it wants to be really flexible and then it receives a request that it doesn't recognize? How should it behave? What should it do? What if we want to add new features? Well, here's call transfer, a mechanism that didn't exist in SIP initially. We've got a call going between Alice and some kind of maybe secretary or something, or just talking to Carol, wanting to talk to Bob. And we ask the Carol to transfer the call into Bob. Well, then they made a new method called refer. So same kind of SIP message, but a new command up at the top, telling Alice's phone, I'd like you to call a new address, and that forces or instructs or other refers, as the name says, begs the Alice phone to call to a new address. But the idea is that to the end user, this looks like you're just moving an existing call. And this is one way of extending the SIP protocol by making up new commands in the protocol. So refer is one mechanism that gives us various kinds of call transfer, but then we have quite a few other ones as well. Refer is fairly advanced, but then we have message for instant messaging, simple instant messaging solutions, and subscribe and notify for creating presence scenarios. I think we may have a slide on that in a few seconds. Another sort of advanced thing in SIP that you usually run into after a while is the back-to-back user agent. What is it? Well, the name indicates that it's back-to-back something, and user agent means terminal. So it's some kind of application server that acts as phones. But what is that allowed to do? When you send a request through a proxy, it was very restricted what it's allowed to do with the messages. So what's a back-to-back allowed to do? Of course, we talk about that. Luckily, the rules are in one way simple, but also kind of strict. So understanding that is, of course, very important if you've got SIP firewalls, so-called session border controllers, since they are usually working as a back-to-back user agent. And here we have then the SIP event framework. If you've heard of presence, you've probably seen these subscribe and notify messages. You subscribe to someone's presence on the network, and then you get notify messages as that user is out to lunch or idle because the screensaver turned on their computer or something like that. And that's what some people think that subscribe and notify is all about. But it turns out that subscribe and notify is a framework for generic event management in SIP. So it can be used for a whole heap of different subscriptions. We've got presence, of course, we've got reg event, message waiting services, and a lot of other useful applications as well. But the really important thing to learn about subscribe and notify is that now we're creating those SIP dialogs again. And that's where we had all those complicated rules about Dialog State, record routing, and all those things. And those need to be applied here as well, otherwise presence will not work. And finally, of course, security. Not just making the protocol secure, of course that's an issue as well, probably adding things like SSL or IPsec or at least some kind of authentication of the end users. That's an issue in itself, and of course media security with SRTP. But we also of course have the annoying problem of firewalls and NAT, so that the existing security mechanisms that we already have in our network, we need to do something to be able to make SIP work through them. Because if you have firewalls, if you have NAT, a simple SIP client will not work. It needs to have support for NAT traversal or help from the SIP firewall with things like an application layer gateway that modifies the SIP messages. So there's quite a few things to understand to be able to know why SIP or VoIP in general has problems with firewalls. But then of course the generic idea of how do we make this secure. Thanks a lot for listening. I hope this has given you some idea of all the complexities of the SIP protocol. I know that with a few hours you can learn the basics of SIP, and that's what I like about the protocol, that it is fairly easy to understand the basics of it. But to fully start working with it and understand the routing mechanisms, and especially to troubleshoot it, that does take quite a lot of studying to learn all the intricacies of the protocol, and of course the mechanisms that it uses, like DNS and underlying TCP and UDP and whatever it might be. But I hope this little seminar has given you an insight into how much there is left to learn, and maybe it tempts you to become even better at the SIP protocol. Hope to see you again.